Hey guys, my name is Abhishek and welcome back to InnoScript. And in today's video, we'll be talking about fault-tolerant distributed systems. So in our earlier video, we have talked about monolith versus microservice architecture and how distributed systems come into play there. So if you have not watched this video, check it out in the description and go back and watch that video. And so the distributed systems, when I say distributed systems, so it will consist of many simpler, maybe the services. Let's say one service is talking to another in a interaction flow, and it is also talking to maybe, let's say, tens of other services. So these kind of interactions are very common when the distributed systems come into picture, and errors are inevitable. So any one of your these services can go down at any point in time. So errors are inevitable. So how do you build your system fault tolerant? That means even if one component of your entire architecture fails, it does not impact the other component of your system. How do you build systems like that? So we'll be talking about that. So I'll be taking an example of InnoScript here. So let's say tomorrow InnoScript start listing different kind of courses on its website, and they're paid courses. So a user will have to come here, subscribe to InnoScript, and will have to make the payment in order to get the courses. So user will interact with InnoScript to make the payment, and in turn InnoScript will make a call to maybe the payment gateway that it is using. It might be anything Cashfree or Razorpay or anything else. So a particularly one third-party system to make this payment happen. So what could go wrong here? So maybe let's take a case where payment gateway is maybe down, for example. So what kind of failures can be there? So there can be one failure where the payment gateway itself is down, and whenever InnoScript makes a call to payment gateway, it directly gives 404. Okay, it directly gives 404 that I am unavailable. So in that case, InnoScript can give one standard error message to the user that our payment gateway is maybe not available, please try out after some time. So maybe a standard error message can go back to the user. Okay, so this is one kind of failure where the payment gateway is down. So this is immediate failure. Okay, so the other kind of failure can be that payment gateway is not down, but it is slow. Okay, so let's say user makes a request to InnoScript, InnoScript makes a request to payment gateway, and it is not down, but it is slow. So it gives the response in back, but it takes a lot of time. So let's say I'll particularly talk about how Java Spring Boot framework works. So usually there is a thread pool. So let's say there is a servlet thread pool which handles the user request. So when user makes a request, there's one thread that gets assigned to this request, and it will in turn go to the payment gateway and make the request. So let's say payment gateway is slow and it is taking a lot of time to respond, and within that time there is another user that comes in, he makes another request, there is one more thread which gets created, and it also calls the payment gateway. So like this, if payment gateway is very slow, then there can be multiple parallel users who are trying to make the payments at the same time. So there can be multiple such threads which are just waiting for the payment gateway to respond. So what will eventually happen is this servlet thread pool will get exhausted, and when it gets exhausted, our InnoScript website itself will go down. So the fault in payment gateway is bringing InnoScript, the complete system, down. So this is the cascading effects of failure that we are seeing due to second kind of failures, which are not immediate but are due to the slowness of one particular component or the buggy servers there. Okay, so the example that we took was very simple, where there were only two components, but in a microservice design there can be, and the distributed systems, there can be a lot of microservices which are dependent on each other in the user interaction flows. So what would eventually happen is, for example, let's say this particular microservice is down and these other microservices are also interacting with this. So this service going down would eventually cascade its effect to this service, and this will eventually cascade its effect to this service. So this eventually, the cascading effects of failure can bring down your entire system. So that's one problem with the second kind of failures that we have seen. So now we will talk about how to handle each kind of failures. So we'll talk about how to handle each kind of failure. So the first failure that we had was an immediate failure where InnoScript makes this call and gets the 404 immediately. So it is able to give back the response to the user that this is down. But let's say there are 10 continuous requests which have failed to the payment gateway. That means that payment gateway is actually down. So why to make 11th call? And why not return the response back to the user that saying that payment gateway is down? And why not give some time to payment gateway to maybe revive itself and come back to life? Okay. So for that, what we could do is we can implement a request interceptor, which means that all the requests from the user will be coming to InnoScript. InnoScript will eventually use this request interceptor, will wrap this request inside this, and this will eventually make the request to this. So we can implement some kind of counter here, which counts the number of failed requests. Let's say this is a very simple counter which takes account of, let's say, the 10 continuous requests have failed to payment gateway, and if the threshold of 10 is reached, we can, from the 11th request, we can just give back the response to the user with some standard error message, right? So this kind of things can be implemented. So instead of this counter, right, which is very fixed, and we do not know how is the load coming to our system. Let's say if I get 10,000 requests, will the counter hold true? That won't hold true. So we'll talk in terms of percentages. So how many failed request percentage has been in a particular window. So that makes more sense. Okay. So percentage makes more sense. How much percentage of the requests in a particular window has failed, and depending on that, I'll have rules whether to make the request to payment gateway or directly return the response. So the thing that we are talking here about is known as the circuit breaker pattern, which means that we would be having something similar to how the electric circuit works, right? So like this. Okay, so our request interceptor will act like a circuit breaker, which says that, so this is an open state right now, and when I have to depict the closed state, it is like that, right? Okay, so it can decide the state whether I want to be open or closed. When it is closed, it means that all the requests will be going to the payment gateway. When it is open, it means that I won't be sending the request to payment gateway. I'll be returning the response back, right? So coming back to the circuit breaker pattern, so there can be mainly the three states. One is closed state, where the interaction will happen; open state, where the interaction won't happen, the standard error message will be returned to the user; and the half open state, where we are trying to make just the set of requests to check whether the payment gateway has come up or not. So we will have certain kind of configurations into our system, which means that we'll be deciding a error percentage, right? If the error percentage goes beyond this, then we would want to break the circuit. We want to bring the circuit from closed state to the open state for a particular time period. So we'll be having the time window as well in the configuration, right? And then we might be having a buffer size which is in the closed state. So let's say in the closed state, I would want to take only a certain percentage of requests, and after that I would want to say that the circuit is open. And when the circuit is there in this state, I would like to define the configuration, how many requests, how much percentage of requests should start going in a half open state. Let's say I would just want to forward only the 2% of the traffic to payment gateway to start with, to just check whether the payment gateway has come up or not. Because in these kind of systems, when a particular component goes down, I need to give them a time to come back. So let's say when the system is slow, I would like to give them the time so that it recovers its state, the CPU utilization, the memory, etc. It comes down and it is able to take a certain percentage of load. So in half open state, I just make the calls to the payment gateway and check whether it is up or not, and I'll be able to decide that and decide whether to close the circuit or not. Okay, but there are other things also involved here. So let's say different developers implement the REST patterns in different ways. They have different error codes that they use in, right? So you need a specific in your configuration, the configuration list that we are listing, we need a custom predicate to decide whether this error means error to me or doesn't mean error to me. So this configuration should also contain the custom predicate, okay, and the event listener as well. So when I say event listener, it means, for example, if I'm just reading the HTTP request, so it would listen to that particular request. It will have a predicate saying that if the payment gateway returns me, let's say some particular error codes 409, something like that. So that means error to me. So in that case, you count this as an error and increase your error percentage for that particular window, and then break the circuit for the time window. So question here is that how does circuit breaker helps in building fault tolerant systems? It helps because one thing is that the cascading effects of failure do not happen in case you have the right timeouts on your systems, the connection timeouts, the read timeouts, you have the right configuration for that, and you are able to break the circuit in case one part of the system is going faulty or it's going buggy and it is causing slowness into your system. So the circuit breaker helps in avoiding the cascading effects of failures, because the failures in one part of the system, for example, the payment gateway that we took, as we have broken the circuit, it won't be able to affect the InnoScript capability, and just the payment feature would be impacted, whereas the users will be able to see the listing of courses, maybe browse through the courses, and also watch the other kind of stuff. So all other capabilities are not impacted just because of the payment gateway failures. So it avoids the cascading effects of failure, and also allows time for other components to get revived. So usually the cases are that the payment gateway, it is facing a lot of load at a certain point of time, and if you break the circuit for that particular period, then it is able to revive again, and it will be able to serve your traffic immediately after that. So these are the kind of things that circuit breaker patterns helps you in. Okay, so there are different libraries in different languages, frameworks that give you the solution of circuit breaker out of the box. So I'll be talking about mainly two libraries. One is Hystrix. So Hystrix is a library which was implemented by Netflix. Okay, and there is another library which is Resilience4j. Okay, so this library is the recommended one by Netflix also, but it is not developed by Netflix, but it is motivated by the Netflix Hystrix library, which implements the circuit breaker pattern out of the box for you. So I recommend that you use Resilience4j, and I'll be posting the links to these two GitHub repositories, Hystrix as well as Resilience4j, in the video description. They have a code example also on how you can implement those patterns into your services. So explore that, and please type in comment if you need more help in implementing those kind of patterns into your microservices. So in this video, we covered the one important piece of fault tolerant distributed system, which is the circuit breaker pattern. In our further videos, we'll be talking about the bulkhead design pattern and the rate limiting, etc., which are like the finer patterns which usually the microservices use. So stick to this channel. Thank you.